Hello everyone. Today we are going to learn about classification model and different learning steps in classification model of machine learning. The learning outcome of this session are: at the end of this session, student will be able to understand the concept of classification model. They get acquainted with classification learning steps. Now let us recall what is supervised learning. As we know, supervised learning contains label training data. For example, we have a data set with name of the student, their aptitude and communication skill marks, and based on that they are classified as a speaker, intel or leader. The aptitude and communication marks are based on scale of 10. So as we can see here in this data set, the student with higher aptitude marks and higher communication marks can be identified as a leader, while the student with low aptitude mark but better communication skill can be identified as a speaker, while the student with better aptitude mark but less communication skill can be identified as an intel. So in this case we can say this is a label data because here input variables are name, aptitude and communication, while the output variable is a class, that is the final output, whether the student belongs to leader, speaker or intel category. So this type of data set is called as a label data set or label training data. So this label training data contains past information with known value of class. Class is nothing but a category, or we can say it is a output variable. So in terms of machine learning, supervised learning which contains label training data is an experience or prior knowledge or a belief. This supervised learning, as we say, it works on label data. On contrast to this, we have unsupervised learning also, which does not contain label data, which contains only input variables. That is called as unlabeled data. Here we don't have output variable. We need to identify output variable based on different techniques. There is one more learning technique called as semi-supervised learning, which uses some part of label data and some part of unlabeled data. So supervised learning which contains label data, some examples of the supervised learning are prediction of results of a game based on past analysis of results. Then prediction whether a tumor is malignant or benign on the basis of analysis of the data. Price prediction in domains such as real estate or stock market. So these are some examples of supervised learning where we can learn using label data and some historical information. Now let us consider first two examples, that is predicting whether a tumor is malignant or benign, and the second example, the price prediction in the domain of real estate. Means first is predict whether tumor is malignant or benign, and second is property price prediction. Now tell me, are these two problems are same in nature? Just think that these two problems are about prediction. Are these two problems are same in nature? No, these two problems are not same in nature, because in first case there is a prediction of category or class. That is, here we are predicting whether a tumor is malignant or benign, while in the second case there is a prediction of absolute value and it is not a class. We are predicting the price of the house or price of the real estate. So here it does not belong to any class, it belongs to some value. So to predict a categorical or nominal variable, we have to use classification method, while to predict a numerical variable or continuous variable or some absolute value, we need regression algorithm. That's why these two are not same problems in the nature, though these comes under prediction. Now classification model. As I told, for supervised learning, we have label training data. So as shown here, we have the label training data with the data of the students with aptitude and communication marks, and based on the, and along with that we have their class also. So this data is with all input variables and output variables. This data is passed to the classifier. Then this classifier chooses a proper classification model for the data. Then the model is trained. After training, the model is tested on the new data set. As shown here, the name Josh with aptitude marks 5 and communication marks 4.5, this data is not present in training data set. So this data is called as a test data set. But based on this, the data set provided to the model, it will predict to which class this belongs. So the model predicted that it belongs to class Intel. So this is how classification model works. So as we can say, classification is a supervised learning where target feature means output is of categorical type. It is predicted for test data based on the information gained from the training data. Target categorical feature is also called as a class. So typical classification problems are like image classification, disease prediction, win-loss prediction of games, prediction of natural calamity like earthquake, flood, etc., and handwriting recognition. All these comes under classification problems. Now let us see what are different learning steps in classification. The learning steps which we are studying now, all these learning steps belongs to machine learning, all types of machine learning algorithms. So first is problem identification. So you need to identify a well-formed problem with well-defined goal and benefit, and which has some long-term it has long-term dependency, or it has some long-term benefits to the society. So identify such problem. Once you identify the problem, then there is a need to identify the required data. So these the required data is on the basis of the problem which you identified. So you need to gather the data from multiple sources which will define your problem precisely. Then once you gather the data, the next step is data pre-processing, which is very important step. In data pre-processing, the data is data cleaning or data transformation is done. As you collected data from the raw sources, some irrelevant information may be there, some noisy data may be there in the data set. So it is required to remove the noisy data, remove irrelevant data, handle some missing data if present in the data set. So data pre-processing is nothing but the transformation of the raw data into required format, so that we can use that data set directly to the for the algorithm of the machine learning. Once the data is pre-processed, we can say that now data is ready. Now data is ready for processing or data is ready for analysis. So once you get your data set, then you need to identify which data is you are going to use for training and which data you are going to for testing. So basically in machine learning, the data is divided into 80% training and 20% testing, or 75% training and 25% testing, like that. So define which part of the data you are going to provide for the training phase. Once you selected the training data set, now the most important or crucial task is algorithm selection. While selecting algorithm, you need to identify some parameters related to that algorithm. Once algorithm is selected, you have to test, you have to apply that algorithm on the training data set which you have chosen in step number 4. So once you apply the selected algorithm on the training and you get the better result, then you need to evaluate that algorithm or that model on the test data set. So if it works properly on the test data set, if it gives correct result on the test data set, then you can say that yes, the algorithm chosen by you is a good classifier. If not, then you need to change some parameters of the algorithm, and you need some parameter tuning to get the best algorithm selection, or also you need to gather more data. Again you need to pre-process it, again you have to select the training data set, and again adjust the parameter of the algorithm, and then again evaluate it. So these are what the basic learning steps of the machine learning algorithm. So there are some classification algorithms, common classification algorithms, that is k-nearest neighbor, decision tree, random forest, support vector machine, naive Bayes classifier. So these are common classification algorithms, and we are going to learn the k-nearest neighbor classifier in next video. So this is the reference for this video. Thank you.